Look at the two cannonballs in the picture. If they are dropped at the same time, which one do you think would hit the ground first? One of the cannonballs is fired horizontally. The other is dropped from the same height. One has vertical motion. The other has vertical and horizontal motion. If both cannonballs are dropped at the same time, they both fall at the same rate. So what does that mean? Since they're both subject to gravity, both of the objects will hit the ground at the same time. A projectile is an object that continues moving by its own inertia, and the only force acting on it is gravity. Some examples of projectiles are a ball that's dropped, or a ball thrown up in the air, or a ball thrown to someone else. Projectiles move along a curved path. If air resistance is ignored, projectiles will have a parabolic trajectory. Most motions in nature follow a curved path. For example, the arc of a basketball, a swimmer diving into a pool, or a dog chasing its tail. What would happen to a projectile if there was no gravity? If there was no outside forces, the coyote would continue moving at a constant speed in the same direction. If we add gravity back in, the velocity is no longer constant, and gravity makes the object fall faster. He accelerates in the y direction, but the velocity remains constant in the x direction. To find the displacement, velocity, or acceleration of a projectile, first we separate the vectors into components. Then apply the simpler one-dimensional forms of the equations for that component. Then we can recombine the components to determine the resultant vector. Be sure to apply the kinematics equations in both the horizontal and vertical directions. A car drives over a 150-meter high cliff at a velocity of 15 meters per second. How far will the car travel before hitting the ground? So use the x and y table below to help you solve this problem. We know that y, the distance, is 150 meters, and the velocity in the x direction is 15 meters per second. The first thing we need to know is the time. How long did it take before the car hit the ground? So we only look at the y distance to find that. So distance, or displacement, is equal to 1/2 acceleration times time squared. So the acceleration due to gravity is 10 meters per second squared. We can rearrange this equation to get d equals 5 times time squared. And when we solve for t, we can see that t is equal to the square root of d divided by 5. So our distance was 150 meters divided by 5. So t is equal to 5.48 seconds. Now, time is the only thing that is the same on the x and y components. So if it's 5.8 seconds for it to hit the ground, it traveled horizontally 5.48 seconds. So now we can find the distance that it traveled in the x direction. Distance is equal to velocity times time. So 15 meters per second times 5.48 seconds So the displacement in the x direction is 82.2 meters. A cannonball is fired from the top of a hill horizontally with a speed of 25 meters per second. How long is the cannonball in the air? If the hill is 50 meters high, how far in the horizontal direction will the cannonball go? So we know that y, the displacement, is 50 meters, and the velocity in the x direction is 25 meters per second. So t for y is equal to the square root of d divided by 5. So t is equal to 3.16 seconds. That means that the projectile traveled 3.16 seconds in the x direction also. So d is equal to vt. So we have 25 meters per second times 3.16 seconds. So the cannonball traveled 79 meters in the x direction. What speed does a cliff diver need to run at to be able to reach the lake 2.7 meters from a 27-meter tall cliff? So we know that the distance in the x direction is 2.7 meters, and in the y direction is 27 meters. Our first step is to find time. T is equal to the square root of the distance divided by 5. So t equals 27 divided by 5. So the time is 2.3 seconds. So now we need to find the velocity that the cliff diver needs to run at. V is equal to distance divided by time. So we have 2.7 meters divided by 2.3 seconds. So the velocity is 1.17 meters per second.